Hello, Year 12. Right, this is a short video just going to introduce the photocell practical. This is where we're going to investigate the photoelectric effect and ultimately come up with a value of Planck constant from the linear graph that we're going to plot. If you remember, we're going to plot a graph of stopping potential against frequency. It should be a straight line. We're going to use the gradient to find Planck constant. So all very exciting. Quite excited to see what value we get. Anyway, here's a piece of kit we're going to use. You'll see this in the next couple of videos. This is the photocell. This is the specific metal in question that has a specific work function. That's going to liberate the electrons when photons come in, and we can measure a current in that circuit. Now we can alter the voltage and find something called the stopping potential, which, if you remember, can enable us to find the exact amount of kinetic energy that the fastest electrons have. So that's really useful to us in the photoelectric equation. So let's just have a little recap of that. So the photoelectric equation is, okay, photon energy, HF, is work function plus kinetic energy of the fastest electrons. Okay, but if you remember, work done equals charge times voltage. So we can replace the EK max with the charge on a single electron multiplied by stopping potential. Just going to rearrange this to make that the subject. That's going to give us HF minus psi. And then finally, we're going to take E over to the other side. So we've got stopping potential equals H over E times F minus phi over E. Should not be unfamiliar to you, this theory. So this is the important bit. Vs is going to be plotted on our y-axis. F is going to be on the x-axis, which means the gradient is h over e. So that's how we find the Planck constant. So just to remind us, y equals mx plus c, so y equals mx plus c. Okay, that's on the y-axis. That's the gradient. That's plotted on the x-axis, which means that minus psi over e is our y-intercept. Right, so this is the graph you're going to plot. Okay. And yeah, because we've got minus psi over e, we actually get a theoretical negative y-intercept. And then we get that straight line there. So that's a value of frequency, because if you remember, that's our independent variable frequency. That's our Vs. Okay, so this is, if you remember, the threshold frequency, and then we're going to use the gradient. So the gradient is Planck constant over the charge of a single electron. Easy. Okay, right, just one thing, this y-intercept here, yeah, this is this can tell us the work function. Don't forget, this is not phi, this is psi over e. Okay, now in this case, we are using the photocell we're going to use. The piece of kit has a cesium antimony plate. It's actually a mixture of two different elements, cesium and antimony. Okay, that can be used together as an alloy. And just done a bit of Google research, they give us a work function of 1.65 electron volts. So this thing here should be giving you a work function of 1.65 electron volts, in theory. Anyway, let's find out. Right, there you go, there's a little intro. Okay, next couple of videos I'm going to show you, I'm going to run through the practical with you. The first one looks at how we measure the frequency, the different frequencies of the light we're going to shine on the photocell. And in the second one, we're going to measure the corresponding different values of the stopping potential. Okay, thank you very much. See you in the next video.